Hello Middle 2. Today let's talk about one of the very important theorems in geometry, which is an Euclidean theorem. If we have a triangle A, B, C right angled at A, and from the right angle we draw a line AD perpendicular to the hypotenuse BC. In Euclidean theorem, to find the length of AB, the area of the square drawn AB, if we draw a square on AB, its area equals BD times BC, the length of BD times the length of BC. So the AB power 2 or the area of the square drawn on AB power 2 equals BD times BC. This part BD times the hypotenuse BC. So AB power 2 equals BD times BC. By the same way, if we want to find the length of AC, the area of a square drawn on AC, if we draw a square on AC, its area equals the length of CD, this part CD, times the length of the hypotenuse BC. So AC power 2 equals CD times BC. And to find the length of the line AD, we have two rules to find this length. The first one, AD power 2 equals the length of BD, this part, times the length of CD, this part. The red times the green. AD power 2 equals BD times CD. And we have another rule to find the length of this side, which is the side AB times AC. The two sides of the right angle, AB times AC over the hypotenuse BC. So AD equals AB times AC over BC. Let's take an example. If we have a triangle ABC right at A and AD perpendicular to BC, the length of BD equals 9 centimeters and the length of CD equals 16 centimeters, and we have to find the length of AB and the length of AC and the length of AD. From the Euclidean theorem, the length of AB power 2 equals BD times BC. AB power 2 equals this part BD times all the hypotenuse BC. So AB power 2 equals BD times BC. BD equals 9 centimeter and BC, the length of the hypotenuse, equals 9 plus 16. BC, all the hypotenuse, equals 9 plus 16 equals 25 centimeters. So AB equals square root 225 equal 15, and don't forget to take the square root for the result. By the same way, to find the length of AC from the Euclidean theorem, AC power 2 equals what? Equals CD, this part, times the hypotenuse CB. So AC power 2 equals CD times CB. CD equals 16 and CB we said that equals 25. 16 times 25, 400, and don't forget to take the square root for 400. So AC equals 20 centimeters. To find the length of AD, we said that we have two ways to find this length. The first one, we take the rule of the Euclidean theorem, AD power 2 equals the part BD times the other part CD. AB power 2 equals BD times CD. So AD equals the square root of 16 times 9 equal 12. And we have another way to find the length of AD by using the rule AB times AC over the hypotenuse. Again, AB times AC over the hypotenuse BC. 15 times 20 over 25 equals 12 centimeters. We have another example. If we have a triangle ABC, right at B, and BD perpendicular to AC, and the length of AB 8 centimeter and the length of BC 6 centimeter, we have to find the length of AC, the length of the hypotenuse AC, and the length of BD and the length of CD. To find to find the length of AC from the triangle ABC, which is right at B from Pythagoras theorem, which was studied in middle 1, AC power 2 equals AB power 2 plus BC power 2. To find the hypotenuse AC from Pythagoras theorem, AC power 2 equals AB power 2 plus BC power 2. So AC equals the square root of 8 power 2 plus 6 power 2 equals 10 centimeters. So the length of AC equals 10 centimeters. To find the length of BD, we said that BD, we have two rules to find it. The first one, BD power 2 equals CD times DA. BD power 2 equals CD times DA. But we can't use this rule because we don't have the length of CD or the length of DA. So we can use the second rule, which is ABD equals BC times BA, the two sides of the right angle, BC times BA over the hypotenuse AC. So BD equals AB times BC over AC equals 8 times 6 over AC 10 centimeters equal 4.8 centimeters. The last side, to find the length of CD, we have no rule to find CD in Euclidean theorem or Pythagoras theorem. So we have to use the rule of the side BC. BC power 2 at Euclidean theorem equals CD times CA. BC power 2 equals CD times CA. So BC power 2 equals 6 power 2 equals CD. We want to find this length times CA equals 10 centimeters. To find the length of CD, we have to divide 6 power 2 divided 10. 6 power 2 equaled 36 divided 10, so CD equaled 3.6 centimeters. So CD equals 3.6 and AC equals 10 centimeters. So we can find the length of AD. How can we find the length of AD? We can find the length of AD by subtract AC, the length of the hypotenuse, minus CD to find the length of AD. So AC 10 minus CD 3.6, we will find the length of AD, which is 10 minus 3.6 equals 6.4.